last video on average rate of change, notes at least, Kevin opened his first checking account and made an initial deposit of $1,140. The table below shows his account balance after X number of weeks. So we're given the chart there, and then the question says, what is account's average rate of change between his initial deposit, week 0, and week 3? So if we look at what we're working with here, we're going to work with this column, week 0 and week 3 for this problem. So when we come back over here, our order pairs are going to be 0, 1,140, and 3, 1,255. And we're going to put this back into the formula to calculate slope. So I'll label the points, and then it's going to be the change in y divided by the change in x. And when we do the math here, we get 115 divided by 3, which comes out to approximately $38.33 for the average rate of change between week 0 and week 3. If we take a look at the same chart, and this time what we're going to look at is we're going to look at average rate of change between weeks 7 and 12, then week 7 is here, and week 12 is here. So when we go back and we fill in this particular chart, what we have then is our two order pairs are 7, 1,560, and 12, 2,100. And we'll label the points, and we'll calculate out our average rate of change, which is also known as slope, by taking 2,100, change in y, minus 1,560, divided by 12, minus 7. And feel free to use Desmos. I don't have the option of pulling up a calculator or anything, or Desmos, on what I'm recording on, which is an iPad. So hopefully I've done my math correctly ahead of time, but when I calculated this out, I get 540 divided by 5, which is $108 for our average rate of change. And we actually have one more on this same example that we can take a look at. And when we look, we're going to look at week 0. And we're going to look at, here's week 0 and week 12. And when we come over here, our points are 0, 1,140, and 12, 2,100. But we're going to calculate our average rate of change. Here's x1, here's y1, here's x2, there's y2, and we'll fill that in. We get 2,100 minus 1,140, 12 minus 0. And again, hopefully I have typed my math into Desmos correctly. But I get 960 divided by 12, which equals 80. For our average rate of change between week 0 and week 12. And as we finish here, if we were to graph these values as points, do we think that the graph would be linear or nonlinear, and why? Well, if we go back to our first calculation, we ended up with 38.33. That's our average rate of change, also known as slope. Our second average rate of change was 108. Again, average rate of change, which is also known as slope. The average rate of change for our part C that we just calculated is 80. All three of those numbers are different numbers. So what we have to say on this particular problem here is that this would be non-linear. And the reason that it's non-linear is that the average rate of change, I'm going to get wordy here, average rate of change is different it would have to be the same. I'm going to try to put a period in there. It would have to be the same value. The average rate of change would have to be the same value for each of those increments, and they are not. So it would not be a linear graph if we were to graph it.